Okay, so we have our domain and range and discrete and continuous notes. So first we're going to talk about is domain and range, what they mean and how we find them. Then we're going to talk about discrete and continuous. What's the difference between discrete and continuous? Then we're going to talk about how those two things are related to each other, because our domain and range kind of change based on if we're talking about a discrete graph or situation or a continuous graph or situation. So first thing we're going to talk about is the domain. Domain and range are super easy once we understand them. The domain is just all of the input values. Well, what's that mean? Really, it just means it's all the x values. And that's just about all there is to it. All of the things that can go into a function is the domain. All of the things that are x's. So for example, if I have a table like this one, my domain is all of my x values. So this is my domain here, is all of my x's. My range, on the other hand, is all of my y values, so all of the output values. So my input values, my output values. And these are my y's. Other times we'll have a graph though. So this is where discrete and continuous comes up. So let's talk about discrete and continuous. Take a look at the two graphs that we have, and what do you notice? Well, the discrete has dots. Continuous is usually one line. But regardless, it's made up of lines always, not dots. So this is discrete function, dots. Think about that. Discrete, dots. D, D. Those are pretty easy to keep together. Discrete, dots. Continuous is usually one line. And for the purpose of this chapter, it's just going to be a line. It might curve. And it might be straight. So those are our two options, discrete and continuous. So for this, now I'm going to find the domain of this right here, and then I'm going to find the range of this right here. So my domain of this specific function is the x values. So when we write a discrete function and we're talking about the domain, we write, and this is just a little syntax, it just looks different. This is the squiggly bracket, and then x, and then the pipe, x, such that x equals, and then I'm listing all of the points that x can be. So it can be 1, 2, 3, 4, and 5. And then I close it with a bracket. So x such that, that's how we read that pipe, x such that x is equal to 1, 2, 3, 4, and 5. That's my entire domain. There's 5 points. I have 5 spots for my domain. The reason we have to write our domain like this is because there's no middle ground. Between 2 and 3, I don't know what my output would be. There's no line connecting them. So that's my domain. Here's my range. Same idea, but now I'm going to label what is coming out. And my range always deals with my y values. So y such that y equals, and now I'm going to list all of my values. Order does not matter. 2, 3, 4, and 6. I do not need to list the 2's twice, because that's not it. All I'm trying to do here is list the output options. So there you have it, guys. That's my domain and my range. Side note, is this a function? Does it pass my vertical line test? Oh, this would be a function because it passes my vertical line test. Every input has exactly one output that goes with it. Okay, now continuous. This is our straight line. So in this case, when we do domain and range, we do it a little differently. My domain is my possible x values. So if we take a look at it, okay. If I take a look at my domain, it's all of the x values here all the way through to here. If I draw a line cutting off where my x values stop. Because outside of these lines, over in this spot and over in this spot, I don't know what's going on with x. I only know what's going on with x between these two spots. Kind of get rid of my markings there. I'm going to do it in highlighter so it's a little bit easier to see. So I only know what's going on from here to there. So here's how we represent that. I can ditch my pen. There we go. So my domain, which is always my x values, is going to be my lowest spot on the x-axis, which is -1. Less than or equal to x. Think back to the Desmos and how we wrote that. Less than or equal to, well, what's the highest it can be? It's 3. And then I close off my bracket. So there's my domain. Notice that these were closed dots, so I have the equal to option. Now for the range. The range always deals with the y values. My y values start way up here. There's nowhere I could go even higher than 8. All the way down to here, which is -1, -2, -3, -4. So I'm going to write my smallest y value, which in this case is -4, which is less than or equal to y, which is less than or equal to 8. My smallest number has to go here. My biggest number has to go here. So make sure your smallest number goes first. Biggest number is the last thing. Make sure we write that in our notes. Write that down. Okay. So that's how we deal with discrete versus continuous with domain and range. Your homework looks just like this guy, and you have to go through and do exactly what we just talked about. So you're going to go in and you're going to look at, okay, what's the domain and range? Well, here are my x values, so I'm going to list my x values. Here's my y values, my outputs, right? Inputs, outputs. X's, Y's, domain on top, range on bottom. Here I have some discrete ones because they're dots. Here I have some continuous ones because they're lines. Discrete, continuous. This one also says to determine whether it is discrete continuous, right? And it says of the function. These are both functions because every input has exactly one output. The last thing we need to talk about is how do we know if something is discrete or continuous if we don't get a graph. Instead we just get a situation. This is going to let me write it. Oh no, not responding. That's okay. One second to find what I'm looking for. This guy down. Okay, so discrete. Discrete things tell me that there's only one option. There's no in between. So for example, if you go to the store and buy tires, I think they'd let you buy 3/4 of a tire. Do you think they'd be okay with that? They'd be like, oh, you only want 3/4 of one? Yeah, we can do that. No, I mean, I'm sorry, you have to buy the whole tire. So if we thought about our domain for buying tires, well, it'd be 0 because you could buy no tires. You could buy 1 tire. You could buy 2 tires. You could buy 3 tires. You could buy 4 tires. You could buy 5 tires. They probably have a limit. You probably couldn't buy like 300 tires because they probably don't have that many tires at the store. So you have a limit of how many tires you can buy, but that's all integers, 0, 1, 2, 3. No negatives, so that's my domain there. Well, if I have a continuous one, like if I'm buying gas, can you buy half a tank of gas? Yeah, I can always buy half a tank or a quarter of a tank. You don't have to buy exactly 6 gallons. You can go in and say, oh, I'd like this much gas. So you could buy different amounts of that. All right, so that's discrete continuous. Oh, sure, now this is up and running. If you guys have any questions on this, let me know. You all have that homework sheet that I was just showing you. This guy, if it comes back up, it's not responding again. It'll be fine. Good work.